Okay, let's take a look through this study guide. Now, keep in mind here, this is not meant to be exhaustive. Clearly, we've covered a lot more types of problems than are listed here. This is just a broad overview of the major topics. So starting at the beginning, displacement. Remember those problems we did where you go up and down an elevator and we find the displacement and the distance. Remember finding displacement and distance from a graph, all those kinds of problems. Remember how to find velocity and acceleration from displacement or vice versa by taking derivatives or antiderivatives. Then we have our constant acceleration problems where we have this set of equations, like projectile motion kind of problems. All kinds of good projectile motion problems we can do where you're jumping off a cliff or throwing a football or whatever. Know how to do all those. Like these are a couple good examples. Know how to draw free body diagrams, find all the forces on an object, um, frictional forces, normal forces, tension forces, all that kind of stuff. You know you're going to have some kind of inclined plane problem. Could be a related to work, or it could be related to, finding the distance something travels or whatever. Work a bunch of different inclined plane kinds of problems. And then, of course, tension problems. We could have like something maybe with a pulley or just a hanging sign with two different ropes hanging it up and finding the tension on everybody. Any of those kinds of problems. You know, I like the circular motion problems where a car is going around a curve and we either want to find like what's the fastest speed it can go or what is the minimum coefficient of friction necessary to keep it without skidding, those kinds. There are two different versions of this problem here. Understand everything there is to know about work. Remember, work is always force times distance times the cosine of the angle between them. So if they're at 90 degrees, the work is 0. Don't forget about power. People always forget about power. It's just work per unit time. Conservation of momentum kinds of problems. Not all conservation of momentum problems are collisions. Like we could have somebody firing a gun, say on ice, and then the projectile goes one way and the dude in the gun goes the other way. That would be a good conservation of momentum problem. Make sure you remember what impulse is. All the rotation and torque problems are kinematic equations for constant angular acceleration. Like you'll have your formula sheets. You don't have to have any of the formulas memorized, but understand how to use them. And then, like, we've done a bunch of good torque rotation kind of problems, like the ones where you've got a sphere and a cylinder at the top of the hill, and who gets down to the bottom faster, or the problems we did on test 3, where you've got that fire escape mechanism where with the big disc, that kind of problem. I like that one. Make sure you know how to do all these kinds of problems. And then static equilibrium problems, where we have sum of forces equals 0 and the sum of the torques equals 0. One of these is going to be on there. Do plenty of those. Gravity, most gravity problems are plug and chug. I can ask a couple of conceptual questions about gravity. Make sure you understand how to get orbital velocity and escape velocity. You don't have to memorize how to derive those, but make sure you know how to use them. Fluid problems. The fluid at a depth, This is the way we learn this formula is FB equals weight displaced. That's what would be on your formula sheet. The buoyant force equals the weight displaced, the weight of the fluid. And then Pascal's principle here. These are like the hydraulic lift kind of problems. Something like this here could show up. No density, understand density. Could ask a lot of conceptual questions about any of these topics, but in particular about fluids. Simple harmonic motion problems. So mass on a spring, um, understand how to relate potential kinetic and total energy in a mass on a spring kind of problem. Then all the stuff we did with waves, there's really not much we can do with waves. Mostly it's just here's a wave in formula form, pick out all the parameters. We did have the stuff with, like in a guitar string, the formula for that relates the wave speed with the tension and the linear density. Know how to use that formula. And then sound problems. So we're talking Doppler's effect here. We're talking, I have no idea what it's trying to say with this formula. When I had it generate this, I've literally just now noticed this. Oh, that's the Mach number. Okay. Okay. Yeah, the way we wrote it was not V object. Okay. Sorry. It confused me for a second. Yeah, that's just our formula for Mach number. So Doppler effect problems and Mach speed, sonic boom kinds of problems. You do not have to have these memorized. I will give them to you. So yeah, just like study everything we've done all semester. That's a good place to stop.